Right, let's do the test here. First of all, let's look at this. Let's see, we got minus 4x to the 5th plus 24x to the 4th minus 40x to the 3rd plus 32x. Now looking at that, I see an x in each of the terms, as well as I think at least 2, maybe 4. Yeah, 4 goes into all of them. So, and I might as well take out the minus 2. So I'm going to take out a negative 4x and look at what I have left. That would be x to the 4th minus 6 x to the 3rd plus 10x squared minus 8. So what I need to factor still is this part. Now I'm going to type into the original equation into my calculator just so that I have everything here. So there is the original equation. So if I push graph, I get something that looks like this if I'm in Zoom 6, Zoom Standard. Now, with that, let's get the reflection out of there. That doesn't hit right on over here between minus 0 and minus 1, but it looks like it goes through 0, which this factor coming out here says it should go through 0. And it looks like we got a bounce at 2. Now, it may not be exactly 2. It might be a little above or below, but we can certainly check that by doing synthetic division. And I would expect you to be doing this on yours. Now, this is the 0, so we want to check in this. And I need to put all the powers of x from x to the 4th down. So 1x to the 4th minus 6x to the 3rd plus 10x squared. What? Oh, there's no x's. So 0 x's minus 8. I'm going to check whether 2 is actually a 0. So 1 plus nothing is 1. Add down, multiply, add down, multiply, add down, multiply, add down, multiply. It did go in evenly. And it looks like it's a bounce. So I'm going to try 2 again into what's left. So 1 plus nothing is 1 times 2 is 2. Add, and I get negative 2. Multiply, negative 4. Add, multiply. And it did go in evenly again. Oops. And therefore, now, originally we started with x to the 5th, pulled out an x, and now it's x to the 4th, pulled out an divided by x minus 2, got x 4, 3, this is x squared, minus 2x minus 2. That's a quadratic. So to get full points, you should use the quadratic formula. So our a is 1, our b is negative 2, and our c is negative 2. And so the formula, x equals the opposite of b plus or minus the square root of b squared minus 4 times 1 times negative 2. That's going to be plus. 4 times 2 is 8 divided by 2 times 1, 2a. And I can see that 4 plus 8 is 12. 12 is the square root of 3 times the square root of 4. The square root of 12 is that, and the square root of 4 is 2, so it's 2 square roots of 3. So this would be 2 plus or minus 2 square roots of 3, all divided by 2. So 2 into that makes 1, and 2 into this makes plus or minus the square root of 3. And now I found all zeros. So let's go back up here and put them. So we have, first of all, we had 0 from this. Its multiplicity is 1 because that's a single factor. So it goes straight through. And then we found 2 happening twice because that bounced. And then we found these 2. 1 plus the square root of 3 and 1 minus the square root of 3. Each one of those is a single, and they're so it goes straight through. And so I should be able now to completely factor this. Now, some of you didn't look at this, but look down here. But if I look here, it says I have an x minus 0 or an x minus 2 twice, and an x minus this would be minus 1 minus the square root of 3, and x minus that would be x minus 1 plus the square root of 3. But there has to be a minus 4, and this would just be a positive x to the 5th. And there's supposed to be a minus 4. And we saw that when we pulled it out here also. So that's what f of x factors to. And to check it, you could type this into your calculator and see whether it graphs exactly like the original. Y-intercept, put 0 in for the x's, that's going to come out to be 0. End behavior. This is a 5th degree, so one end goes one direction, one goes the other, and it's negative, so that instead of the negative end going down, the negative side will be going up that way, coming in, and then it'll eventually go this way. They're going to go opposite. So that's indication of their behavior. Local maximums. Well, let's go back to the calculator here. We can see it came down, so there's a minimum, then it went up to a maximum, down, and to another maximum. So there's 2 of them. One in here somewhere between 0 and 2. So to find that, I'm going to go second calculate the maximum between 0 and 2, and I'm just going to guess at about 1. And it says what happens at 0.72, but the maximum is 13.79. The other one is between 2 and 3. So second, calculate the maximum between 2 and 3, and I'll put something in between there, 2.5. And it says it's really close to 2.5, and the height is 1.88. Now, if I'd ask you the points where the maximum are, then you'd have to give me the x and y. But if I ask you for the maximum is how big the y value is. Okay. Determine the intervals where this is positive. Well, it's positive all the way up to that spot. Now, that spot is somewhere between 0 and negative 1. And that would have to be that answer. So from negative infinity up to 1 minus the square root of 3, it's positive. Then at that 1 minus the square root of 3, it's actually equal to 0. And then it's negative, and then it's positive starting at 0 and up to 2. But at 2, it goes to 0. It actually touches, so we don't want to include that, so that's why we have to stop there. And we could go again because it just goes right back up to positive and then heads down to negative. And that negative spot is got to be another 0, which must be this other one, 1 plus the square root of 3. So from 2 to 1 plus the square root of 3, and that would be all the places that this is positive. Okay, so that was number 1. Number 2. So the first thing I ask you to do here is to factor this. Well, the denominator is already factored. In the numerator, we can pull an x out. So that would be x times x squared minus 4. And that factors, the x squared minus 4 factors. So there's the completely factored form. Now, besides factoring, it also, there's one that looks almost the same except for the whole. This is, by the way, is going to be causing whole. What it's going to look like is this one. So there's a whole at where this would be 0 is at 2 for the x, and we'd plug 2 into almost the same form to find the y value. 2 times 4 is 8, and 2 plus 5 is 7, so 8 sevenths. Okay, vertical asymptotes. That would be what causes the denominator to be 0, but that's the whole, so not that one, this one. So that would be x equal negative 5. And when I'm asking for behavior at a vertical asymptote, I want to know whether at that asymptote, do they both go up in the same direction or down in the, both go down, or do they go opposite directions? And since it's a single factor, they go in opposite directions. Okay. Now determine whether it's horizontal or oblique. Well, the degree of the numerator was 3. The degree of the denominator would be x squared. So that's the degree in the numerator is larger by 1. And so it has an oblique asymptote. And to find it, we do long division or synthetic division if possible. Now this, we could multiply these together and divide it into their long division. But since this simplifies to one that will have the same oblique asymptote, this one, I can divide the x plus 5 into numerators x squared plus 2x plus nothing. So x into x squared is x. X times this would be x squared plus 5x. I draw the line, change the signs, and add, and I get negative 3x plus nothing. And x goes in there, and negative 3. And I don't care if it goes even. I've got enough here to know what the oblique asymptote is. Y equals x minus 3. And let's see. Oh, now I could have done this with synthetic. To do that, I put in 1x squared, 2x, and the constant 0. And what makes that be 0 is a negative 5. 1 plus nothing is 1 times negative 5. Add negative 3, and there it is. Now, if there were two factors here like this, if I was trying to do it on this, I couldn't do that. Or I could divide by the one of them, take this whole thing, take this original one. Let's actually do that, just so you can see how that works. If I was still back here on this one, I have 1x to the third, 0x squared minus 4x plus 0. I can go in with the minus 5. That'd be 1 plus 0 is 1 times negative 5 is negative 5. Add, I get negative 5. Multiply, I get negative 20, or positive 25. Add, I get 21. Multiply, I get 105. Negative, so negative 105. But I don't care that it didn't went evenly. I just want to work on this one. And now I have to put the minus. Let's see, the x minus 2, which should be put in a 2. I'd have 1 plus nothing is 1. 2 times 1 is 2. Add negative 3. And I can keep going, but I don't need to. Won't go in evenly. But I have y equals 1x minus 3. So I used synthetic and divided one of these in, and then the other one into what was left, and I still come up with the same oblique asymptote. So, X-intercepts. Well, the X-intercepts come from the numerator being equal to 0. Again, that's a whole, so it won't be an X-intercept, so we've got one at 0 and minus 2. When y is 0, we get 0. Y is 0, we get negative 2. And since these factors each happen once, it's going to go straight through. Okay? Y-intercepts. If I put 0 in for the x's, I'm going to get 0 times stuff over stuff, so I'm going to get 0, which makes sense. It says right here, went through 0, 0, so that's also going to be the y-intercept in this case. All right, so now we need to graph all of the stuff that we figured out here. And the first thing we figured out was the whole, so I'm going to put that on there. That was at 2/8. That's 1 1/7. The next thing I found out was a vertical asymptote at x equal negative 5. And the graph has got to go opposite on either side of that. One side it goes up and the other side goes down. We're not sure which is which. Next thing, we found out there was an oblique asymptote at y equals x minus 3, so minus 3 with a slope of 1. So that's going to look like that. And then we have x-intercepts of 0, 0, and negative 2, 0. And so if it's going to, the curve is going to go through those places, and the y-intercept is 0, 0. If it's going to go through these 2 points and to here, it has to be, can't be going this way, and that wouldn't make this a very good asymptote, and it would have to go down. So it most likely looks like it goes like this. And over here, it would be about the same distance out and going similar. So that's what the graph would look like. Now, when is this function, all of this part and this part, less than 0? Well, all of this part is less than 0. That's from negative infinity up to negative 5. And it's less than, so it can't equal, and besides that's an asymptote, so we can't include the negative 5. Union, and then only this little piece here is less than 0 also. It's equal to 0 at minus 2. It's equal to 0 at 0. We don't want to include either of those, so we'd have to go from negative 2 to 0. Okay, that's number 2. Let's go to number 3. So we've got to write a 4th degree polynomial. Well, one of the zeros is plus 4, one's minus 4. One is this complex, and if it's going to be a polynomial, it won't have complex coefficients, and so to get that to happen, you have to have the conjugate of this. Another way to think of that is like the quadratic formula. The quadratic formula would go minus b plus or minus something with the square root, and that's where this comes from. And so the other one has to be minus 1 minus 3i. And so in factored form, this polynomial would be x. For the plus 4, we'd have minus 4. For the minus 4, we'd have x plus 4. For the minus 1 plus 3i, we'd have x minus a minus 1, which would be plus 1, and minus the 3i, because it's x minus the 0. So that's why it looks like that. And the other one is x minus the other 0, so the minus of this would be plus 1 plus 3i. And that's what the polynomial would look like. It could have a number out here. You can put something in if you want, but you don't have to. That's the simplest one. Okay, number 4. So we have a double 0 at negative 3. So we know it bounces at negative 3. We don't know whether it bounces off the top or off the bottom, but at negative 3 it bounces. It goes through 2, straight through, because it's degree 1, straight through at 2, and straight through at 3. And if I look at this, I have x times x, so that's x squared, times the negative x, that's negative x to the third, times the negative x, that's positive x to the fourth. Well, positive x to the fourth is going to go up on this end and up on this end. And so if it bounces here and then goes straight through and then straight through, it must look something like that. So when is this curve above the x-axis? A positive. Well, it's positive or equal to 0. It's positive or equal to 0 all the way up to 2. So from negative infinity, clear up to 2, and including that, it's either 0 or more. There's only this little bit that isn't greater than 0, and then the rest of it is positive. So union from 3 to infinity, including the 3. And finally, number 5. Well, it looks like it bounces at 2, so that means x minus 2 must happen twice. goes straight through at this place, whatever we want to call that. I'm going to call it x, looks like about a negative a third, so I'm going to go x plus 1/3, but whatever you want to call it, a quarter, 0.25, 0.4, 0.3, point whatever. And then it looks like it bounces here, or hesitates here at -3. So that means that x plus 3 times. So this would be it, except that we may have to put a constant in here to adjust it so that it hits at about 1. Now let's see what happens. So if x is 0, y is supposed to be 1. Y is supposed to be 1 when x is 0. So 0 minus 2 squared is 4. 0 plus 1/3 is 1/3. And 0 plus 3 cubed is 27. It's not 3 times 3, but 3 times 3 times 3. A third of 27 is 9 times 4 is 36. So I have 1 equals a times 36. And so I divide both sides by 36, and I get a equals 1/36. And so now I can write my whole thing, the whole polynomial function out. F of x equals 1/36 x minus 2 squared, x plus 1/3 to the 1, and x plus 3 cubed.